You can see it, right?
Yes.
For example, this is the flash. So I want to find out this gap. I think the cross section is not in the correct view. I mean, a view is correct, but it seems like this should be like a line.
Okay.
But it still shows like a curve to me.
Yeah.
So which means it's not in the 2D plane.
Okay.
You have to change it into 2D plane.
Okay.
So if that is the gap, and you have to always start from the left of the gap, right?
Left, yes.
And this is my 1. And from there I go to the end, as you mentioned.
Yes.
Okay. And you should come to this point here.
Okay.
So from here you should come to this biasing point, because the green color part is biasing to the blue color part, right?
Right.
So that dimension will be there anyway.
Okay.
And from that you have to go all the way to here.
Okay.
Because the green color part is biasing to this cyan color or light blue color part at this location.
Yes.
So what you have to do is you have to always check for those two components biasing point, where those two components. So first we are starting from the gap of this knob.
Yes.
Okay. Yeah. And the knob, you have to come to knob and the other part, like green color part, where it is mating.
Yes.
Because what is the relation between blue color and light blue color part here? Because we are finding gap between those two parts.
Yeah.
What is the relation between those two parts is blue color and green color part relation.
Yeah.
And green color to light blue color part relation.
Yeah.
So then you have to come from here
back to
here to back here, and from here to here. Yes. And here what you have to check is
tolerance
and datum plane. If your datum plane is not this one, if your datum plane is this one, then what you have to do, you have to come from there to datum plane, and datum plane to this dimension. Okay. And generally what I follow here for the biasing points, I'll take a small circle. And add it like this. Okay, so that this is biasing point, and I'll mark it with the biasing point, something like that. Okay, this is one, and this is another. You can give a different color, no problem.
Okay.
So this is another biasing point, and from here I would consider coming from here to all the way to this face. So then I'll get my gap. Okay. So now what you have to see is only the green color. Actually, green color part is not a flexible part. There is something else which is connected to the green color part. I think this is a gray color part, I guess.
Gray color, yes.
Yeah, because gray color part is the one moving forward, right?
Yeah.
So then what you have to do, this one is coming green. Okay, green is anyway sliding,
Yeah.
and once the green color part slides, it will stop here,
Yes.
right?
Yes.
Okay, so that's where actually hard stop. So you no need to consider the gray color part then.
Okay.
Okay, so for example, if this surface is coming at the maximum material condition, so that will change the gap here.
Okay. Yeah.
And if the same green color part comes at the maximum material condition here, or blue color part slot comes at maximum material condition, then that also can change this gap.
Yeah. Okay.
So that's why we are adding all those things here.
Okay.
For example, if your datum is here for the sorry, not if your datum is here on the knob,
Yeah.
then no need to go to all the way to the back.
Yeah.
From this datum, you can go to this slot,
Okay.
and from that slot, you can keep the data biasing point, and from there, you can go to the green color part.
Yeah. Correct.
Okay, no need to go all the way to this.
Okay.
So that depends on biasing point between two components and the dimension which is coming from the datum
Yeah.
in that particular component.
Okay.
Okay, yeah, that you can check. And now from here 1, 2, if it comes 3, otherwise you can make this one 3. Then all the way you come here. For example, if this is datum is here, then you have to split this arrow
Okay.
from here to here and from here to here.
Okay.
Because just remember, when we prepare the drawings, right? So all the dimensions for any feature, for a hole or for any feature, the position of the hole or something, it has to be dimensioned from datums.
Right. Correct.
So either A, B, C, whichever direction it is.
Yeah.
Okay, so when it dimension from datums, so because datums are already qualified, first datums we will qualify. So when datums qualified, so then with respect to datums we dimension other components. So that's how the loop comes.
Okay.
Okay.
Yeah. Sure.
You
I'll
want me
check. I'll
to
check with
send
the
a
drawing.
screenshot?
Yeah, that would be great. So Hari, if we consider the third one that you mentioned from the end of the knob to green part, how do we find the dimension for this one?
This one, okay, let me. Do you have the drawings open
Yes.
for
Yes.
these
I
three?
have open. I have it open. Let me share it. So
Okay,
we need for button endo close, the knob, the pusher.
And the green color.
The green
I don't
is
know
the
what it
pusher.
Pusher,
Yeah.
pusher, and this housing
the
and this
needle.
button.
Okay. Let me share it. This is the knob, if you can see my screen.
Okay, yeah. So this is the knob, and where is the datum A here? This circle, right? This circle is datum A.
Yes.
So which won't come in this direction, and datum B is this slot. Oh, they don't have a flat face datum. Huh? This one or this one, they don't have any datum here. Then how they defined it? They're supposed to have some datum here, here or here, but they don't have a datum. Then what you can do is, okay, this is 250, the thickness. Only A, B's are there. This is parallel to B. Okay, then you can take this as datum C, this space.
Are you pointing something, Hari?
Oh, okay. I need to take control. Okay. Just provide me control. I requested for it.
Yeah, give
Okay.
it.
This one, you take this one as datum C.
Okay.
Okay, because this is an important phase which is interacting with the other component on this side only. Because the other side, it is not interacting with any component. Only thumb will be there.
Yeah.
Right?
Yes.
So take this dimension, and from there, because you have a flash here, and that flash height 24,000.
Yeah.
You can take the 24,000 flash height, and the default you can give, take 23,000 flash height and consider plus or minus 1,000 or plus or minus 2,000
Plus minus.
as a tolerance.
Okay.
Yeah, plus minus 2,000 you consider as a tolerance.
Okay. The flash we gave was 22,000.
Yeah, 22,000.
Okay.
No, we gave 23,000. This is not the drawing that you uploaded.
Okay. Yeah. Right. 23 was given. Yes.
Yeah, just delete the drawing from your database. Otherwise, it will be confused.
Yeah.
Okay, so 23,000 we have given.
Yes.
Which means that is a maximum we have given.
Yeah.
Right? So what you can do is probably you can take 20 as nominal.
Yeah.
And 21 is nominal, and make 23,000 is maximum, and minus 2,000 as minimum.
Okay.
Minus 2,000 or minus 3,000, anything is fine.
Okay.
Because minimum we are not concerned about.
Okay.
So maximum, make sure you get your maximum is 23,000 on.
Okay.
So that's how you take 21,000 as nominal and plus or minus 2,000 as maximum plus minimum.
Okay.
Okay. Next is from there you take the flash, right? Okay, from flash you are getting, and from there to here to this face, and from this face, what is your dimension here?
This is 2.250. 20.
Is your needle going all the way down to this hole or this hole?
Just a sec. I think this is the one. Let me just share. Yeah, this thing.
It's like that. Okay, can you measure the dimension in the CAD model, please?
Yeah. Should I do the cross section and then?
Cross section after quad. You just open this. That one. Yep. Just open as a component. Okay, just rotate it. Okay, this has. Sorry. Go to assembly only. Take a cross section. Let's see whether it is assembling to the outer hole or inner hole. You can double click on it. Okay. Take another cross section. Just rotate. See, okay, and rotate. So why it is okay? It seems like it is going all the way to the back. Because there is no hole we can see here, right?
Yeah.
There is some interference.
Yes.
But because we don't have all the features on the component, so that is the reason we are getting interference.
Yeah.
Okay, so then you can go to the drawing now.
Yeah.
This one, 0.125 dimension you have to take.
0.125.
Yes. If you want a confirmation, go back to the assembly and you can measure there.
The 0.125 is from this point till this, but if we want this part, it's okay. Yeah, anyway.
No, we don't need it. No, we don't need it now.
Okay. Yeah, we don't
So
need
because
it. Yes.
because from this face only is going, right?
Yeah.
So, and we are assuming this face is datum C.
Datum.
So you don't need the 250 dimension here.
Yeah.
Okay, so you can start from here.
Yes.
First consider the flash,
Flash. Yeah.
22,000 flash, and from there consider 0.125.
Yeah.
And 0.125 you go to the other side of your pusher.
You're right. This part.
Just open pusher.
Yeah. Okay. The drawing.
Yeah, drawing.
Just a second.
So you have to consider 0.925.
95. Right.
This one also doesn't have any datum, flat datum.
Yeah.
This is round A they have given, and B is slot. And C, no. Okay. So because C is not there, you can directly take 0.925.
Yeah.
With the sheet tolerance of plus or minus 5,000.
Okay.
So when there is no tolerance here, you have to consider the default tolerance from here.
Okay, 5,000.
Yeah, 5,000. Because this is 3 decimal, right?
Okay.
After the decimal, 3 points. So that's why you have to consider 0.005.
Right.
If it is 2 decimal, then you have to consider 0.01.
Oh, okay. Got it, Hari. Yeah.
Okay, and so 3 decimal, this is, that's why maximum you will get 0.930.
Yeah.
And minimum should be 0.920.
Yes.
That's what you have to enter in the stack sheet.
Yeah.
Okay, and so you are going from all the way from there to here, and from here, because this is biasing point again.
Yes.
So from here, sorry, this one I guess.
This one,
Yep.
yes.
From here you have to go to that housing.
Yes. From here, we need to go to this housing, right?
Yes, this housing if you open,
Okay.
let's see what is the datum.
Let me open this quickly.
They have taken stapling as a reference document. Stacks.
Yeah, the stack one. Yes. I was just
So
checking.
stapling is more complex designs. If you take that one as a reference, you will be confused.
Yeah, that was I think just to build the dimension bank. I preferred that. Let me really quickly.
Go to home, remove that 00.
It's not responding.
Okay, it's downloading. So in this, see this face is datum A
Yeah.
here, and from there, cross section. Do we have any cross section?
This is their cross section.
No, not that one. This cross section we have to take section A, which is section A. This one, okay. So this is section A.
Okay.
you needed this dimension 1.093
3. Yes.
because anyway datum is from here, right?
Yeah.
So you can take from the datum, you can take the
This.
dimension all the way here. Oh no, sorry, can you zoom in there?
Yeah.
I think it is touching here, right? Here.
Yes, this one. This one,
0.813 dimension.
0.813. Yeah. This is the rod and the needle.